The ocean is in constant motion, a never-ending dance of water and wind. Waves are a visible and powerful reminder of this energy, showcasing the ocean's dynamic nature. But what exactly causes these waves to form? The answer lies in the wind, a force that shapes the sea. As wind blows across the surface of the ocean, it creates friction, a crucial interaction. This friction transfers energy from the air to the water, initiating a fascinating process. This transfer of energy is what creates the ripples that we see on the ocean's surface, the first signs of wave formation. These ripples, given enough time and distance, can grow into the waves we see crashing on the shore, majestic and powerful. The stronger the wind, the longer it blows, and the greater the distance it covers, the larger the waves will become, creating a spectacular display. It is important to remember that waves are not just moving water, they are a manifestation of energy. They are actually a form of energy traveling through the water, a continuous transfer of motion. This energy is what causes the up and down motion that we associate with waves, a mesmerizing dance of nature. Ocean waves are characterized by three main factors: wavelength, wave height, and wave period. Wavelength refers to the distance between two consecutive wave crests. Wave height is the vertical distance between the crest of a wave and its trough, the lowest point between two waves. Wave period, on the other hand, is the time it takes for two consecutive wave crests to pass a fixed point. These three characteristics are constantly changing, depending on factors such as wind speed, wind duration, and the distance over which the wind blows, also known as fetch. While wind is the driving force behind everyday ocean waves, creating the familiar sight of waves crashing on the shore, tsunamis are a different beast altogether, possessing a power and scale that far surpasses regular waves. These massive waves are not caused by wind, but by sudden and powerful geological events that displace large volumes of water, often with devastating consequences. The most common cause of tsunamis is underwater earthquakes, which occur when tectonic plates shift abruptly. When an earthquake occurs on the ocean floor, it can cause the seafloor to uplift or subside, dramatically altering the underwater landscape. This sudden movement displaces a massive amount of water, creating a ripple effect that travels outwards in all directions, gaining momentum as it moves. These ripples, unlike wind-driven waves, have extremely long wavelengths, often measuring hundreds of kilometers, and can travel across entire ocean basins. Tsunamis can also be triggered by underwater landslides, volcanic eruptions, and even asteroid impacts, each capable of displacing vast amounts of water. Though these events are less common than earthquakes, they still pose significant threats to coastal regions. Section 4. Waves versus tsunamis, a tale of two forces. The difference between regular waves and tsunamis is vast, almost like comparing a gentle breeze to a raging storm. While both involve the movement of water, their scale, power, and the mechanisms behind them are distinct. Regular waves are often rhythmic and predictable, whereas tsunamis are sudden and catastrophic. Regular waves are created by wind and have relatively short wavelengths, typically ranging from a few meters to a few hundred meters. They might be powerful in a storm, but their impact is generally localized to the coast, affecting only the immediate shoreline and nearby areas. Tsunamis, on the other hand, are generated by seismic events such as underwater earthquakes, volcanic eruptions, or landslides, and have incredibly long wavelengths, sometimes spanning hundreds of kilometers. In the open ocean, a tsunami might be barely noticeable, appearing as a gentle swell rather than a towering wave. This deceptive calmness can be misleading. However, as a tsunami approaches shallower coastal waters, its energy becomes compressed, causing the wave height to increase dramatically, transforming it into a massive wall of water. This is what makes tsunamis so dangerous. Their sudden and immense power can cause widespread destruction in a matter of minutes. Their immense power, coupled with their ability to travel thousands of kilometers across the ocean at speeds exceeding 800 kilometers per hour, makes them a significant threat to coastal communities. The aftermath of a tsunami can be devastating, leaving behind a trail of destruction and loss. Section 5. The importance of early warning systems. Because of the devastating potential of tsunamis, early warning systems are crucial for saving lives. These systems use a network of sensors to detect seismic activity and changes in sea level that could indicate a tsunami. This information is then relayed to coastal communities, giving them valuable time to evacuate to higher ground. Early warning systems are essential for mitigating the impact of tsunamis. They provide a lifeline for coastal communities, allowing them to prepare for and respond to these natural disasters more effectively. While we cannot prevent tsunamis, we can take steps to reduce their impact and protect human life.